We now discuss the solution of a problem from the section Sequences and Series. This question is on the concepts of geometric series. This question has appeared in the Joint Entrance Examination Main held on 26th June 2022 in the second shift. The given question is, if A is equal to sigma n is equal to 1 to infinity 1 by 3 plus minus 1 to the power of n whole power n, and B is equal to sigma n is equal to 1 to infinity minus 1 to the power of n by 3 plus minus 1 to the power of n whole power n in the denominator, then A by B is equal to, we are given two infinite series A and B. So A is equal to, that is the sum of these infinite series is A. The infinite series is n is equal to 1 to infinity 1 by 3 plus minus 1 to the power of n whole power n. And the second infinite series is this one, whose sum is B is equal to sigma n is equal to 1 to infinity minus 1 to the power of n by, in the denominator, 3 plus minus 1 to the power of n whole power n in the denominator, required to find the value of A by B. We are given four options. Option A 11 by 9, option B 1, option C minus 11 by 9, option D minus 11 by 3. We now discuss the solution of the problem in detail. Let's now first of all take the first series. A is equal to sigma n is equal to 1 to infinity an, where an is equal to 1 by 3 plus minus 1 to the power of n whole power n. Agreed. Now, if n is odd, then minus 1 to the power of n is minus 1. Then 3 plus minus 1 is 3 minus 1 is 2, and 1 by 2 power n. So, if n is odd, an is 1 by 2 power n. If n is even, minus 1 to the power of n is plus 1, 3 plus 1 will be 4, then an is equal to 1 by 4 power n if n is even. Now, capital A is equal to the sum of the series. The series is sigma n is equal to 1 to infinity a1 1 by 2 because n is odd, plus a2 1 by 4 square where n is 2 which is even, plus a3 n is 3, 3 is odd, 1 by 2 cube, plus n is 4, 4 is even, therefore a4 is 1 by 4 power 4, plus so on and so forth. Now what we observe is there is one series that is running as 1 by 2 plus 1 by 2 cube plus 1 by 2 to the power of 5 plus so on and so forth. The other series that is running is 1 by 4 square plus 1 by 4 power 4 plus 1 by 4 power 6, so on and so forth. So separate them. Now what we observe is the first series is a geometric series with the first term 1 by 2 and common ratio r is equal to 1 by 2 square, and the common ratio r is less than 1. And the second series is a geometric series with the first term a is equal to 1 by 4 square and the common ratio r is equal to 1 by 4 square, which is less than 1. In the case of geometric series, if the common ratio, if the first term is a and the common ratio r is such that mod r less than 1, then the sum of the series up to infinity is given by a by 1 minus r. Now we apply this here, and this is equal to a 1 by 2 by 1 minus r 1 by 2 square plus the second one, the first term a is 1 by 4 square by 1 minus r 1 minus 4 square 1 minus 1 by 4 square. Simplify, 1 by 2 by 1 minus 1 by 4 is 3 by 4 plus 1 by 16 by 1 minus 1 by 16 is 15 by 16. So that is equal to 2 by 3. The first bracket sum is 2 by 3. The second bracket sum is 1 by 15 and the total sum is 11 by 15. Thus, A is equal to 11 by 15. That means the sum of the first series is 11 by 15 given by A. Thus, A is equal to 11 by 15. We continue in the next slide. That's our given question. Now, we have already seen capital A is equal to 11 by 15, the sum of the first series. Now, we will consider the second series. B is equal to sigma n is equal to 1 to infinity minus 1 to the power of n by 3 plus minus 1 to the power of n into n. And you observe that in this minus 1 to the power of n, leave it, and this is 1 by 3 plus minus 1 to the power of n into n all to the power of n is same as an, the nth term of the first series, the nth term of this first series. So, B is equal to sigma n is equal to 1 to infinity Bn, where Bn is equal to minus 1 to the power of n by 3 plus minus 1 to the power of n whole power n, and that is equal to minus 1 to the power of n into this is nothing but the nth term of the first series itself. So, an. And the behavior of an we know. Therefore, Bn is equal to when n is odd, minus 1 to the power of n is minus 1 into when n is odd, an is 1 by 2 power n. So, Bn is equal to minus 1 by 2 power n when n is odd. When n is even, minus 1 to the power of n is plus 1, and that is an. When n is even, an is 1 by 4 power n. So, Bn is equal to minus 1 by 2 power n when n is odd, and Bn is equal to 1 by 4 power n if n is even. We continue. Therefore, capital B is equal to the sum of the series sigma n is equal to 1 to infinity Bn is equal to B1. B1 is minus 1 by 2 plus B2 is 1 by 4 square, and B3 1 minus 1 by 2 cube plus 1 by 4 power 4 minus so on and so forth. As in the first case, now separate them. Then you will get the first one is minus 1 by 2 minus 1 by 2 cube plus so on and so forth. So minus is common. So minus into 1 by 2 plus 1 by 2 cube plus so on and so forth. Plus the second bracket is 1 by 4 square plus 1 by 4 to the power of 4 so on and so forth. The first bracket without minus, the first bracket is same as the first bracket in the first case. The second bracket is anyway same as the second bracket of the first case. Now minus the first bracket is a geometric series with A is equal to 1 by 2, R is equal to 1 by 2 square, which is less than 1. And the second bracket is the geometric series with the first term A is equal to 1 by 4 square and the common ratio R is equal to 1 by 4 square less than 1. And we know the first bracket sum is 2 by 3. So this is equal to minus 2 by 3 plus the second bracket sum is 1 by 15 as in the first case, what we have seen in the first case. And now take the LCM and simplify, you will get this is equal to minus 9 by 15. Thus, the sum of the second series capital B is equal to minus 9 by 15. Now required to find A by B, capital A by capital B is equal to capital A is 11 by 15 by capital B is minus 9 by 15. So the 15 cancels and you will get the answer as minus 11 by 9. A by B is minus 11 by 9. Let's look at our options. Our answer minus 11 by 9 appears against option C. Therefore, our answer to this question is option C. That is the detailed discussion of the solution of the given problem on geometric series from the section sequence and series. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.